Hi, today we're going to do number 104, maximum depth of a binary tree. So we're given a binary tree and we want to return the maximum depth. So we see here we have 3, 9, 20, 15, 7, and the way they represented it on this input is 3, 9, 20. There's two nulls here because it doesn't have any children, and then 15 and 7. So here we see 1, 2, 3. So the maximum depth is the number of nodes along the longest path. So we return 3. So we know that we need to traverse the tree, and there's two main ways to do it. We do it either depth first search or breadth first search. So here, DFS, there's two ways we can do that. We can use a stack or we can use recursion. So with the recursion way, we need to figure out the base case. So if we're at a value where there's null, we just return 0. And then we want to recursively go up the chain. So we return 1 plus. So every time you go down, you add a 1. And then you go down the left side and also the right side. And you want to take the maximum of it. So maximum of left or right side. And then that'll give you an answer. So with a stack, we iterate through it. We know that we need to keep track of the depth. So here in the stack, create stack with the tree root and also the depth. So we need a way to keep track of it, and then we loop through it. We pop out stack, and then we add to pop up the stack and add their children. And then since it's the children, it's the depth of the parent plus 1 with depth plus 1. And then with each one, we need to have a running count. And then we compare the max depth values and update it if it's the max. And then we just return that count. So now with breadth first search, we have to go 3, 9, 20, 15, 7. So we want to create a queue to keep track of it. Root, and then we need a variable to keep track of the count. So I have running depth, but we're going to do it a little differently. We pop from the queue, we get the value, and then we loop through the length of the pop, so the size of it. So here we do it once, but here we do it, we'll do it 2 times since there's 2 values. And in this, we add children to the queue if it has a value. And then outside of this loop, since we want to get everything in that breadth, we do it at the end of the loop. After the loop, increment count, and we return that count. Okay, so since the recursion one, oh, I forgot the time complexity. So since this one, they're all going to be the same. O of n, since we have to iterate through the entire tree, and then the space complexity, we're creating a stack depending on the length of the tree, where n is the length of the tree. And we want to do that the same for the stack as well, because we're iterating through everything and creating a stack for the length, and then for the queue, we're iterating through everything and creating a queue for the length. But yeah, recursion looks like the simplest way to do it, so that's the way I would recommend. So here we do the else case. So if root equals null, return 0. And now we know we're going down level, so it's going to be 1 plus math.max, calling this function again, passing through root.left, or the right side. Great, so that's one way. And the next way, we can do a stack. So if root is null again, we can just return 0, and then we create the stack, and we pass it the root and the depth. So it will start off, since it's not null, it will have at least 1, right? And then we have the max depth. It already has this variable, so we can do a count. And that's what we're going to return at the end. So we do a while stack.length is greater than 0. We pop it. And then we can get the values, const node equals current. The first value, const depth equals current 1. And then if node's a value, we can just update the count. And then here we can push to the stack the left and the right one. And since we're only going to update this if node has a value, is fine. We don't have to verify that the node.left exists or not. So stack.push current.left, and then we do the depth plus 1. And then we do the same thing for the right side. We want to enter in the node, not current. Because that'll be what represents in the tree. And this has to go on the outside here. Great. Now we can do it with a queue. So we keep the same, and then let's create the queue. And we just pass in the root. And now we keep the count. And that's what we're going to return. And now we do while the queue has a value. So why is it not empty? And we have to get the size first, because when we do breadth first search, we want to get everything in that level. And now we loop through for that size. And here we'll get the value. So q const current equals q dot pop. And then now we add it only if there's a value. And then after all of that, we increment the count for that level. Sorry, so there's no length here because the size is already a number. In this case, we only want to add the node if there's a value, unlike the stack one, because in the stack one, we have a validator to check if it's a null value, but here we don't. So those are the three ways we can do this problem. Recursion, where we just have the base case being 0. If it's null, we return 0. And then we do 1 plus everything else and get the max of the left side and the right side. We create a stack, and we need to keep some way to keep track of the depth. So in a stack, we add the root and the depth. And we pop it out, add the children, and then compare the max depth values. And then with the BFS, we create a queue. And then we have a running count of the max depth. And then we have to add to the queue. And then iterate through the current size of the queue to add all the children to it. And at the end of the loop is where we increment the count, and we return that at the end. And that's all. Thank you.